In this video, we're going to take a look at a couple of trig equations, and we're going to imagine what the graphs would look like, and we'll answer some questions about those. So let's start with the equation y is equal to 3 cosine 5x. And let's decide which of these statements are true. So basically we'll just do a true or false on each one of these. It has an amplitude of 5 and a period of 2 pi over 3. I'm just going to look ahead. The next question says amplitude of 3 and a period of 2 pi over 5. So clearly they're asking us about the amplitude and the period, so let's figure that out. I see that the a value is 3. Okay, that tells us that the amplitude is 3. If this were negative 3, the amplitude would still be 3. So the amplitude is definitely 3. That means that A is definitely false, since it's talking about an amplitude of 5. So maybe B is true. I don't know yet, because we don't know the period. So the A value is 3. Now this 5 is the B value. We know a relationship between the period and the B value, because for cosine, the period is 2 pi divided by the B value. So the period should be 2 pi over 5. Okay, so statement B, amplitude of 3, yes. Period of 2 pi over 5, yes. So statement B is true. Alright, it has a domain of negative infinity to positive infinity. That's true. We know that periodic functions like sine and cosine, alright, they just go up and down forever, and they don't stop doing that. Alright, sine and cosine both will look like this. So the domain is negative infinity to positive infinity. Now what about the range? Okay, well, there's no number added on the end. So that means that the midline is the x-axis. Alright, in other words, if there were, let's say there was a plus 2 on the end of that, then that would mean that the midline would be at 2, and then the cosine function would be like going up and down at that spot. But that's not the situation, is it? There is no number on the end, so that means that the midline is the x-axis. Okay, so let's see, we're talking about the cosine function. We already know that the amplitude is 3, so that means 1, 2, 3, 4. That means it's going to start off up here and then go down to negative 3 and go back. Okay, so like here's a quick sketch of one period of the cosine function. And yeah, if the amplitude is 3, that means it goes up 3 and it goes down 3 from the midline. So yeah, the range is from negative 3 to positive 3. That is the range. So statement C is also true. So choice D, both A and C are true. No, A was false. Choice E, both B and C are true. Giddy up. Alright, so as far as multiple choice goes, the answer would have to be E. Both B and C are true. Alright, now let's move on and talk about number 14. Alright, it's a similar type of a game. Let's go through and label these as true or false, and we'll find out if the real choice is E, that both A and D are true. We'll see. Let's just calm down and wait and see what happens. Hold your horses. So let's see. They're talking about the amplitude and period again. So let's break that down. I see that we have an A value of 2. So that means the amplitude is 2. Okay, that's true. That means that statement B is already false, all right, because it says the amplitude is 4, and that's wrong. So it's so statement B is already proven false. So what about it? What about the period? Well, we can see that the B value is 4, and we know that the period with the sine function is going to be 2 pi over the B value, and that's going to simplify down to pi over 2. Alright, so the amplitude is 2, yes. The period is pi over 2, yes. So that means A is true. Alright, what about the range of 0 to 2? That is going to be false. Again, there's no number added onto the end, which means that the x-axis again is going to be the midline. Okay, so the amplitude is 2. So this graph is going to go up 2 and it will go down 2. So the graph is going to look like this. Okay, so the range is from -2 to +2, not 0 to 2. So that's why that's false. Well, I guess I've already answered question D. It has a range of -2 to +2. Yeah, the midline is 0, so -2 to +2. So that's true. Okay, or is the best answer E? Both A and D are true. Ding, 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 ding. E again is the right answer. Both A and D are true. Alright, take a look at number 15. Given that a particular sine function with an amplitude of 3 has a minimum value of -4, what is the function's maximum value? Now, this dotted line that I'm putting down is the midline. It is not the x-axis. I don't know where the x-axis is just yet, but that is the midline. Now, so we're talking about a sine function, so I'm going to graph myself a sine function. Okay, so here's one period of a sine function. Okay, now I'm going to go ahead and put a y-axis down, and again, I don't know where the x-axis is yet. I'll worry about that later. Alright, but right here where the top of this thing is, okay, I'm going to put a mark there, and right here where the bottom of this thing is, I'm going to put a mark there. So those are my guidelines, the midline and the high and the low. So, I know that this function has an amplitude of 3. So for example, if this was the x-axis, it would be up 3, this would be +3, and this would be -3. Or for example, let's say this middle value, let's say the midline was 2. Since the amplitude is 3, that means it would go up 3 and down 3. So if I go up 3, that would be 5. If I go down 3, that would be -1, for example. Okay, now, I don't know any of that. What do I know, though? What do I know? Tell me. The minimum value is -4. So I know that this is going to be -4 right here. So if the amplitude is 3, then the midline must be 3 above this. Okay, so this must be -1. Alright, in order for them to be 3 apart. And then if I went 3 more, then that would be 2. Okay, so think about it. If the midline is -1, and the amplitude is 3, so if I go up 3, that would put me at 2. If I went down 3, that would put me at -4. So this makes sense. But what they wanted was the function's maximum value, which you can see right here. The maximum value must be 2. So that's why the answer is C. Okay, let's play again. Look at problem number 16. The graph of y equals cosecant x has the same set of vertical asymptotes as which one of these graphs? Alright, I think we'll just have to do a quick sketch and see. Cosecant is a reciprocal of the sine function. So if I do a quick sketch of this thing, alright, so here I go, 1, 2, 3, 4. Alright, and this is going to be 1, and this is going to be -1. The sine function has a period of 2 pi, so there's no, the b value is 1, so the period is going to stay 2 pi, so this is pi, and this would be pi over 2, and this would be 3 pi over 2. Okay, so here comes my invisible sine function. You know, the sine function will start here, and it will go up, and it will go back down, and then it will go down and back up. So if I'm graphing cosecant, I leave my sine function as a nice dotted line. Okay, so there's my sine function. Now let's talk asymptotes. Let's see, I want you to be able to see them. I'll use green. The vertical asymptotes are going to be where the sine function touches the midline. So I'm going to have a vertical asymptote here at 0. I'm going to have a vertical asymptote here at pi. And I'm going to have a vertical asymptote here at 2 pi. So 0, pi, and 2 pi. So I'm looking for another one of these functions that has asymptotes at the same places. Now, the sine function doesn't have any asymptotes. Okay? Like here we were about to graph the cosecant function. Maybe I should follow through and say that the actual cosecant function is shown here in red. Okay, this would be 1 period of the cosecant function. The sine function itself doesn't have any asymptotes. Alright, only the I'm only having asymptotes because I'm doing the reciprocal, alright, the cosecant. So I can throw that out. All of these other ones do have asymptotes though. Now, I really know that it's not going to be secant or cosecant 2x. Like I really could throw these out right now because I think I'm going to have to erase this picture up here to make space. Alright, the reason why I know so quickly that it can't be secant is because secant is the reciprocal of cosine. And the cosine graph, there's no way it's going to have the asymptotes in the exact same places. Okay? It's like the reverse. So that's how I know. So if I were going to do secant, so if I start off the same way, this is 2 pi, this is pi, and pi over 2, and 3 pi over 2. Alright, but because secant is the reciprocal of cosine, it's going to start off up high and then go low. Okay, so here goes my dotted line, alright, which is the cosine graph. So again, the asymptotes are going to be where the cosine graph touches the midline. So my asymptotes are going to be here at pi over 2 and 3 pi over 2. So they do not match at all. So I knew it wasn't going to be secant. Now, if I change the b value, that's going to change the period. So the graph would be the same, except the period is going to change, right? Because the period would be 2 pi divided by the b value. So that would be 2 pi over 2. So for this equation, the period would be pi. So the graph would be the same, except for the markings would change, right? Because the period would now be pi. So that means this would be pi, and then this would be pi over 2. Okay? And then pi over 4, like etc. But suddenly now I have an asymptote at pi over 2. There wasn't an asymptote at pi over 2 before. So that's why I knew very quickly, because if I change the period, I'm going to have asymptotes in the wrong places. So it's not going to be cosecant 2x either, all right? It's just taking this graph, changing the period, that's going to mess it up. So no. So it's going to be either tangent or cotangent is what we're down to. So let me erase this mess, and let's take a look at tangent and cotangent. Alright, let me start with tangent. So man, you really have to know your stuff to be able to answer this question. This is a really powerful question. So y equals tangent x. Let's take a look at that, people. Alright, you need to know, if I do one period of the tangent function, you need to know that tangent begins and ends on the midline. So if this is my tangent function, tangent is going to begin and end on the midline like that. And then there's going to be an asymptote right down the middle. Okay? Now, the thing that makes this a little bit special, we got to watch out for it, is that the period of tangent and cotangent are going to be different than sine and cosine. Sine and cosine, and therefore secant and cosecant, they have a period of 2 pi. But remember, tangent has a period of pi, and so does cotangent. So that means this is pi, and that means this is pi over 2. Okay, and then I could, this would be pi over 4 and 3 pi over 4. But notice I have an asymptote at pi over 2. Okay? Do we have an asymptote at pi over 2 for the cosecant function? No. So that means it's not going to be tangent. That means the answer is going to be C, right? That's the only one that's left. But now let's take a closer look and see why that is. Okay, let's do this last graph and see why that it's cotangent. So when we did tangent a moment ago, we saw that tangent begins and ends with a dot. Okay, the period begins and ends on the midline. And then there was an asymptote in the middle. Cotangent is the reverse. Cotangent begins and ends with an asymptote. Alright, and right in the middle there's a point. Okay, so let's look at this. Again, cotangent has a period of pi. So this would be pi, and then this would be pi over 2. Okay, and pi over 4, and 3 pi over 4. And this is 0. So, notice we have an asymptote at 0. This has an asymptote at 0. We have an asymptote at pi. This has an asymptote at pi. And look, the period is pi. So if I go another pi, I'm going to have another asymptote. So if I go 2 pi, that's a full period. So of course I'm going to have another asymptote at 2 pi. So cotangent is the one that has the asymptotes in all the right places. So the answer is C. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.